Okay, welcome to today's class. In today's class, I want to design some equations for a motion of a body along a horizontal path. That is a horizontal projection. Now, how do we get these equations? Let's see. We have a body that is moving in this direction. This is the table. The body moves in this direction. So this is the, we're here to this place. Sorry. I have motion is in this direction. This is the motion of the body. So this place is the angle, and this is ux, this is uy, and this is v. So from here to here is the horizontal distance. This is the horizontal distance. Then how do we calculate the height and the horizontal distance? So we're going to employ one of the equations of motion along a horizontal line. So you have this equation: x is equal to ut plus half at squared. This is one of the equations of motion. So how do we relate this one to this diagram? What we now do is we say that for this one, Sx is equal to, when we are considering horizontal motion, horizontal components, we have ux t plus half axt squared. But in this type of motion, the ux is equal to u and ax is equal to 0. So we say this one is equal to r. That's from here to here. So wherever we see this guy, we substitute this. So we now have r is equal to ux is u. We have ut plus half a is what? 0. Half times 0 times t squared. So the whole of this equation becomes ut. This is the horizontal distance from here to here. This is the formula for it. I can call it equation 1. So if I make t the subject, I will have r over u. Call this guy equation what? 2. So now this is the time it takes the body to move from this one down to this place. Now recall that if I have sy is equal to, still from this equation, uyt plus half ayt squared. I can now say that where uy is 0, ay is g, and I can say sy is what? H. That's the height. So wherever I see sy, I'll put h equal to uy is what? Uy is 0. 0 times t plus half a is what? Gt squared. So I can now have my h to be half. This is my height, half gt squared. Call this one equation what? 3. So what I'm going to do now is I want to substitute equation 2 into equation 3, meaning that wherever I see this t, I will put the whole of this term. And that is going to give me h equal to half g. You see, t is the whole of this. That is r over u all square. And this will give me r square over 2u square. That is equation what? 4. So that is the path traveled by the wave. Sorry, by the object. So now if we want to have designed this, and this, if I want to represent this in a vector component, I can now say that bringing it in this form, this one, if I close here like this is alternate to this, meaning that here is theta, this is v, this is uy, sorry, ux, this is uy. Okay? Now what I will do is I will now say that recall from this equation that say V is equal to U plus AT. This is the first equation of motion. Now, what we are going to do is Vy, okay, let's start from X equal to Ux plus AXT. Okay, now Ux is 0. Sorry, Ux is U, Ux is U, and the AX is 0. So wherever I see Ux, I will substitute U. This will give me U plus 0 times T. So Vx is going to be equal to what? U. So that is the value of my Vx. Now let me design for Vy. I can now say my Vy is, you see, Vy is equal to Uy plus Ayt. So wherever I see my Uy is 0, my Ay is G. So in that case, I'm going to have Vy is equal to 0, 0 plus GT. So my Vy becomes what? GT. So that is my Vy. Okay, what I will do is the components, the magnitude of the velocity, that is V square, is equal to Vx square plus Vy square, which means V square is Vx is, look at it, U. You can see it here. So this is U square plus Vy is GT. So I have GT all square. So this is giving us U square plus GT or what? Square. This is one of the equation 5. So this is one of the velocity. That's the magnitude of the velocity. So in that case, I've designed this. If you want to get the angle will be in this format. The angle will be in this form. We say that tan theta is giving us opposite, that is Vx over Vy. So my theta, that means Vx, we say that Vs is U and the Vy is, you can see GT. So I have tan theta equal to U over GT. So theta will give me tan inverse of U over GT. So this is the angle. So this is the angle. So these are the various equations. Okay. So thank you and remain blessed.